In the previous video, we saw how the formulas for the trigonometric functions using a point on the terminal side of an angle corresponds to the right triangle definitions in the first quadrant. In this video, we're going to extend the connection even further and connect the definitions to all four quadrants. For any point xy in the plane and not on one of the axes, we can define an angle theta in standard position. Here's what it looks like in each of the four quadrants. Using the point, we can also create a right triangle using the x-axis as one of the legs, and the line connecting the point to the origin as the hypotenuse. The angle of this triangle at the origin is what we call the reference angle. We will denote it using the Greek letter rho, which is the Greek letter r, even though it kind of looks like a p. Notice that rho is always measured relative to the x-axis and never the y-axis because rho is inside the triangle. Furthermore, it's always an acute angle. Using these diagrams, we can use simple geometry to determine the reference angles. There are formulas you can memorize, but it is much better to be able to use logic to arrive at your answers. It's just a matter of thinking about how the angles add or subtract to get an easily identifiable angle. Once we've identified the reference angle, we can then get the values of the trigonometric functions by using that angle. For example, let's look at an angle in the second quadrant. From this angle, we can create a triangle just as we described. The triangle that we have created is just a mirror image of a triangle in the first quadrant. Specifically, it is a reflection across the y-axis. This means that the y value would stay the same, but the x value changes signs. The key idea here is that we can always relate everything back to an angle in the first quadrant, and then just change the signs to get the values in the appropriate quadrant. This gives us a useful geometric way of thinking about the trigonometric functions. As a numerical example, let's look at the angle that passes through the point -4, -7. Here's what our triangle would look like with the reference angle labeled. If we reflect this angle into the first quadrant, we can identify the sine, cosine, and tangent of the reference angle, using the Pythagorean theorem to get the length of the third side, and then using the geometric relationships of opposite, adjacent, and hypotenuse. We just need to remember that the tangent is the only positive primary trigonometric function in the third quadrant. We could actually do the same thing with the original triangle, but we would have to work with the idea of signed distances, which means that we would have to allow for negative distances. This can be made to work, but it can be a bit confusing and prone to error. It also turns out that reference angles have other uses that we will see later on in the class, so it's worth taking the time now to develop some of those core concepts. We have now seen several different approaches to calculating the value of the trigonometric functions. In the next video, we will add one more.